Good morning, students. So, how was the exam? It was easy. Good morning. How was the exam? Okay. Good morning. Good morning. Okay. How was the exam? Anyway, today we are going to talk about organic chemistry, that is basic principles. Anyway, so techniques we will not discuss because it's not there. So only basic principles I have written. Ashish, it was easy. Oh, very good. I am very happy. Good. So all of you have performed nicely, right? Good, Appa. Fine. So we are starting with new topic. Whether board is visible? Organic chemistry, basic principles. Whether board is visible for all of you? I think it should be visible, but I don't know. Okay, visible. Okay. Fine. So I am very happy that you people have performed nicely in your exam. Very good. So we will start with the new topic that is called as organic chemistry, its basic principles. Okay, organic chemistry and its basic principles. Hagadre. When I am talking about organic chemistry, right? They will tell now organic farming and all. So what do you mean by organic farming? So where they will not be adding any of the synthetic fertilizers, right? They are not going to add any of the fertilizers, no pesticides. They are called as organic farming. Fine? Hagadre, who is going to provide the fertilizers and all? In which form? Plants will going to get the nutrients. That is by the natural waste. That will be done by the natural waste produced by the plants itself. Therefore, it is called as organic farming. Hagadre. When I am talking about organic chemistry, because whatever structure of atom, basic concepts of chemistry, and whatever periodic classification and all we have discussed, that was related to actually physical chemistry. Okay. Now, in your syllabus, S and P block elements, all these things belongs to inorganic chemistry. And that's where very few topics are there, that is organic chemistry for first P. But when it comes to second PU, organic chemistry is going to dominate. So you have to remember this one. So when it comes to second PU, organic chemistry is going to dominate. 1 minute. So therefore, if you understand these topics, whatever we are discussing now, naturally you can understand even second PU topics also. Otherwise you will feel it as difficult. Many students, they will feel organic chemistry as the difficult concept in chemistry. But that is not true. Only thing here is when it comes to organic chemistry, you should know the basic principles. That's what we are going to discuss now. Okay? Now, when it comes to inorganic chemistry, balancing the equation is very much required. But when it comes to organic chemistry, balancing the equation will not be very much required. Only thing is you should talk about which is the major product involved. Okay, so that's where I can tell that organic chemistry is bit advantageous. Sir, what is the difference between organic and inorganic chemistry? What is the difference in these two types of chemistry chapters? Yes, Ashish, I'll come to that. I'll come to that. Okay? So, hagadre, what I mean to tell here is your chemistry syllabus will be always divided into physical, inorganic, and organic chemistry. When it comes to first PU, physical and inorganic, they are going to dominate. Okay? And organic chemistry, only 2 chapters are there. But when it comes to second PU, organic chemistry is going to dominate compared to other chapters. Okay? Hagadre, as you people have asked, when I am talking about organic chemistry, it deals with those compounds. It deals with the study of organic compounds and their reactions. Study of organic compounds and their properties or reactions and their properties, chemical properties. So that's where we have the organic chemistry. Hagadre, what do you mean by organic chemistry? Organic chemistry which deals with it is the branch of chemistry which deals with the study about the organic compound and their properties. Now the question here is, what do you mean by organic compound? Because already we have discussed about compounds. So what do you mean by compounds? So these are the molecules which are made up of different elements. They are called as compounds. That all of us we know, right? So what do you mean by compounds? These are the molecules which are made up of different elements. Now I am using the word organic compound. Compounds means these are the molecules which are made up of different elements. That is one thing. Now when I am telling organic compounds, Stefan, naturally occurring compound, not compulsory. Now I am going to tell that one. Organic compounds are those where one of the elements should be carbon. That's where we have the organic chemistry. So it deals with the study of the organic compound and their properties. Okay? Now, if I come to Stefan, he told natural one. So in that case, nitrogen gas present naturally. But they are not considered as organic compounds. Okay? So that's 4. Natural, that word may not be required, but you can specify that carbon containing compounds are called as organic compounds, and study about this organic compound is nothing but organic chemistry. Yes, Ashish, that can be related to alkenes, alkynes, alkanes. Even we have many other types which we are going to discuss in this particular topic. All of you have understood? Now you got the point what I mean by organic chemistry and organic compound, because we have discussed about organic chemistry, which is the branch of chemistry which deals with the study of organic compounds. Then we have discussed about organic compounds. What do you mean by organic compounds? Right? So that's where we have the important topic related to your exam point of view and related to your competitive exam point of view and related to your second PU. Because as I told, in second PU, organic chemistry is the one which is going to dominate, and these are some of the topics you should be very much perfect in these topics. As I told, structure of atoms, then basic concepts of chemistry, then chemical bonding, periodic classification of elements. So these are some of the basic topics. You should be very much thorough. Then you can understand other topics of chemistry. Same way, if you are thorough with these topics, one is this one and another one is hydrocarbon. If you are thorough with these two topics, then easily you can understand rest of the organic chemistry topic of your second PU. Don't postpone. Don't think that, oh, that is in second PU, sir, we will we will look into that. No. Don't postpone the things. Okay? So that's where we have the importance of this particular topic. Now when it comes to the marks, some of the topics, some of the concept has been deleted due to the COVID. Some of the concepts they have deleted from this particular topic. So don't be under tension that by seeing the number of pages, oh, such a large topic, don't be under stress. Now it will not be such a large topic because some of the concept has been removed from this particular topic. I will be focusing only on whichever is there in your syllabus. Okay, don't worry. Now when it comes to this particular topic, with respect to the board exam, you can expect around 5 to 6 marks, even it can go up to 8 marks questions. That means it's a pretty important topic. This particular topic is pretty important with respect to your board exams. Okay? Same way, when it comes to competitive exams, you can expect 2 to 3 questions. That also shows that it is a very important topic. Okay? Now about that, if you know this particular topic properly, then easily you can understand the rest of the organic chemistry topic of your second PU also. So try to understand the topic, and any doubts, let me know. Okay, any doubts, let me know. So that's where we have the organic chemistry, that is the first chapter related to organic chemistry. Now we know that what you mean by organic compounds. Right? So when I am talking about organic compounds, we can classify these organic compounds into different categories. So first one is non-cyclic. Non-cyclic organic compounds. Non-cyclic organic compound, or we can call it as acyclic organic compound, whatever it is. Or we can call it as acyclic organic compounds. That is one category. In the name itself it is there. There is no closed structure. There is no ring or cyclic structure in there. That's what non-cyclic or acyclic meaning. All of you have understood? That's where acyclic or non-cyclic means there is no cyclic structure. Or we can call it as open chain structure. So we can call it as open chain structure. That's where we have the non-cyclic or acyclic compound. Now this can be even called as aliphatic compounds. Aliphatic means related to fats, oils. Aliphar means related to fats and oils. Because they observed that these type of compounds are majorly found in oils and fats in the beginning. Therefore, they kept the name it as aliphatic. So, aliphatic, non-cyclic, acyclic. One category of organic compound. Okay? Now, another category is cyclic. All of you have understood? That's where we have the cyclic organic compounds. Now, if I want to go with first one, if I want to first go with first one, where I can include CH3, CH3, that is ethane. That is ethane. Even I can include CH3, CH2, CH2, CH3, that is butane. I will come in detail with respect to these compounds, don't worry. Even in your hydrocarbons, you are going to study about this compound. They are all examples for non-cyclic compounds. They are all examples for non-cyclic compound. I have taken two examples. Why they are called as non-cyclic? Because we can find the free terminals. These two carbon, they are not attached to any other things, or they are not attached to any other molecules. Therefore, it is a non-cyclic. Same logic is applicable here. So here we have the carbon, here we have the carbon. So there is no question of any non-ending terminal. There is a terminal. Rohan, I will come to pentane and all. First try to understand what you mean by non-cyclic. Okay? Now, to be more specific, I will call it as N-butane. To be more specific, I can call it as N-butane. That N talks about linear structure. That N talks about linear structure. So whether I am clear? So that is one category of organic compound. Now when it comes to cyclic, when it comes to another category, okay, so all of us, we know that they will be having a closed structure, or they will be having a cyclic structure. So cyclic organic compounds are those which are having closed structure or cyclic structure. So in that case, when I am talking about cyclic organic compound, we can have homocyclic, we can have the homocyclic, okay, or we can have the heterocyclic, In a cyclic organic compound, we have once again two types, homocyclic and heterocyclic. Now, homocyclic, in the name itself it is there. So these are the cyclic organic compound which are having only carbon in their ring structure. So these are the organic compounds which are having only carbon in their ring structure. Okay? Now, for example, here I have written N-butane, right? Now, same way I have CH2, 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 CH2. Right? How many carbons are there? 4. Here also 4 carbon, there also 4 carbon. But what is the difference? Difference here is we have one terminal methylate, another terminal methylate. So here there is no question of terminal, there is no end. Therefore they are cyclic structure. This is called as cyclobutane. Now in the ring we have only carbon which are linked with each other. Hydrogens, they are connected to the carbon. But in the ring structure we have the carbon linkage. So therefore it can be an example for homocyclic organic compound. All of you have understood, because it is having only carbon in its ring structure. Okay, outside the ring any element can be there. But when I am talking about that ring structure, I am telling that only carbons are present. Okay. Now heterocyclic means these are the organic compound where we can have, other than the carbon, any other element can be there. Along with the carbon, any other element might be there. They are called as heterocyclic structure. Okay. See, for example, I have an organic compound that is nothing but furan. It is an organic compound that is having, which is nothing but furan. If I observe, here we have the carbon, along with that oxygen is present in the ring. Along with that oxygen is present in the ring. So therefore it can be called as heterocyclic organic compound. Which one? Furan. Okay. Now I can write the same molecule as CH double bond CH double bond. So here also CH. So one and all same. Both is nothing but furan only. Good morning, Appa Dikshit. You are late. You are late to the class. Okay? So that's where we have the furan. Both are related to furan only. Yes, Rohan, you are absolutely right. So we have so many examples for alkanes. I didn't see the message. I think that time only have sent it. Anyway, we are going to discuss about that one. Okay? But for time being, you should know what you mean by homocyclic, what you mean by heterocyclic, and what you mean by aliphatic organic compounds. All of you have understood? So that's where aliphatic is nothing but non-cyclic, acyclic. And when I am talking about homocyclic, we have two types. When it comes to cyclic, we have two types: homocyclic, heterocyclic. In homocyclic, what is there? Only carbons, they are linked with each other in the ring structure. In heterocyclic, along with the carbon, we have the oxygen in the ring structure. Therefore, it is a heterocyclic compound. Which one? Furan. Like that, we have many other examples. All of you have understood? Any doubts? Okay. So anyway, I will remove these examples. I will keep rest of the things as it is. I will remove these examples. Okay. Now, homocyclic organic compound. Homocyclic organic compound, once again it can be classified into aromatic and alicyclic compounds, or non-aromatic. Anything is fine. Non-aromatic or alicyclic. Okay. So not acyclic. Don't get confused. Acyclic is different. Alicyclic is different. Alicyclic is nothing but non-aromatic organic compounds. Okay. So aromatic, aroma, flavor. So there are some of the organic compounds which will give the flavor. There are some of the organic compounds which will give the color. Right? So whenever we are observing the petrol, it will have its own typical smell. Perfume, it will have its own smell. All this is related to organic compounds. When I am talking about tomato, it is having a particular color. Carrot, it is having a color. Apple, it is also having its own color. So all these things are due to one or the other organic compounds. Okay? So that's where we have the aromatic and non-aromatic or alicyclic compounds. Okay? Now same logic is applicable for heterocyclic also, which can be classified as aromatic and non-aromatic or alicyclic organic compounds. Alicyclic organic compounds. So don't get confused. Now, aromatic compounds can be classified as, it is applicable for homocyclic only. One as benzenoid and another one as non-benzenoid aromatic compounds. Benzenoid and non-benzenoid aromatic compounds. Okay? So, when I am talking about aromatic, that is benzenoid and non-benzenoid. So we can give the example of benzene. We can give the examples of benzene to the benzenoid organic compound, that is phenol, benzene containing compound. So what is benzene? Benzene is this one, right? Anyway, in detail with respect to organic compound, aromatic compound we are going to discuss, but for time being you can remember that this is benzene ring attached with the OH. This compound is called as phenol. This compound is called as phenol. An example for benzenoid aromatic compounds. Homocyclic it is because in the ring structure these corners indicates the carbon. Only carbons are present, no other elements in the ring structure. Only carbons are present. All of you have understood? So that's where we have one of the example. That's where we have the one of the example. Now naturally non-aromatic, it can be cyclobutane, it can be cyclopropane, whatever it is. All of them, they comes under non-aromatic or alicyclic compounds. So it can be cyclobutane, just we have discussed. It can be cyclopentane, or it can be cyclohexanes. Cyclohexanes, they are all the examples for non-aromatic alicyclic compounds. Okay, non-aromatic or alicyclic compound. Which one? Cyclobutane, cyclopentane, or cyclohexane. Cyclobutane means 4 carbon in the ring. Cyclopentane means 5 carbon in the ring. Cyclohexane means 6 carbon in the ring. Okay, so that's why we have the non-aromatic or alicyclic compounds. Okay, so that's why we have the homocyclic. Same way, when I am talking about heterocyclic, we have aromatic compound. Cyclic structure with respect to heterocyclic structure, which are aromatic in nature. Okay, just now we had discussed about furan. Just now we had discussed about the furan that can be included under aromatic heterocyclic compounds. That can be included under aromatic heterocyclic compound. All of you have understood? So that can be included under this category. Okay? So there we have similar type of compound. This is furan. This is furan. Now I have tetrahydrofuran. I have tetrahydrofuran. Okay? So I have got the tetrahydrofuran. So which can be an example for non-aromatic or alicyclic heterocyclic organic compound. That is tetrahydrofuran. So furan, where 2 unsaturations are there. So tetrahydrofuran means no unsaturation. That means 2 hydrogen here, 2 hydrogen here. Total 4 hydrogen has been added to the furan. So therefore it is called as tetrahydrofuran. Tetra means 4. So tetrahydrofuran, that means 4 hydrogen has been added to the furan. So therefore there is no double bond in tetrahydrofuran. Since there is no double bond, it will be a non-aromatic compound. All of you have understood? So briefly I can tell about the classification. Organic compounds can be classified into aliphatic or non-cyclic or acyclic organic compound. Naturally, the name itself it is that they does not have the cyclic structure. Now, ethane, N-butane, N-pentane, all of them, they can be an example for aliphatic organic compound. They don't have the ring structure. Okay. Now, if you come to other side, we have the cyclic organic compound, which can be classified as homocyclic and heterocyclic. And homocyclic further can be classified into aromatic and non-aromatic or early cyclic compound, not acyclic, early cyclic compound. Now, homocyclic means which should have carbon in their ring structure. Okay? So that's where aromatic, which can be classified into benzenoid, non-benzenoid. So for benzenoid, we have the phenol as the example. For benzenoid, we have the phenol as the example. Okay? So when it comes to non-benzenoid, we have propelone. I am taking from your textbook. I think it is there in your textbook also. Propelone. So which will be having okay. So this is where we have the propanone, which is the example for heterocyclic, non-benzenoid organic compound. 1, 2, 3, 4, 5. It should have 7. That's why we have the propelone, which is an example for heterocyclic, non-benzenoid organic compound. Okay. Now on the other side, we have the heterocyclic compound, where aromatic it can be furan, and non-aromatic it can be tetrahydrofuran. It can be tetrahydrofuran. Now, in case of the furan, all of us we know oxygen is present along with the carbon in the ring structure, but when it comes to non-aromatic, there is no question of any unsaturation, and there is once again presence of oxygen along with the carbon. So that's where we have the classification of organic compound. Any doubts? That's where we have the classification of given organic compounds. Any doubt? If you have any doubts, you can ask. If you have any doubts, you can ask. So aliphatic, which is also called as acyclic. Then homocyclic can be aromatic or non-aromatic. Heterocyclic can be aromatic and non-aromatic. Okay? Yes, Ashish. Then we will go to next part. This is related to classification. How these organic compounds can be classified into different categories. Okay? Because there are plenty of compounds which are having carbon. So therefore, there is a huge requirement for the classification of these organic compounds to understand their chemistry. That's where we have the aromatic, non-aromatic, aliphatic. We can majorly call it as, we have 3 types of organic compound. One is aromatic, and another one is non-aromatic, and another one is aliphatic. So we can classify majorly into 3 categories. All of you have understood? Okay. Now, some of the terminology you should understand. Now, whenever I am writing CH3, whenever I am writing CH3, it is nothing but methyl group. Methyl group, because all of us we know that a carbon, it will be linked with 4 other elements, because carbon can make the 4 bonds. What is the valency of carbon? That is 4. What is the total valence electron present in the carbon? That is 4. Because it is a group 14 element. Right? So therefore, there will be presence of 4 valence electrons. Okay, now? So therefore, we have methyl, where this particular part, it can be other than the hydrogen. R can be other than hydrogen atom. R can be other than hydrogen atom. It can be another carbon only. Sir, what are the elements in methyl group? I'll come to that, Ashish. First try to understand. So that's where we have the methyl. That's where we have the methyl group. Okay? So from where this one came? This one came from the methane. So we have the methane. Okay? So in methane we have 4 hydrogen attached to the carbon. We have 4 hydrogen attached to the carbon. In that, 1 hydrogen will be replaced. In that, 1 hydrogen will be replaced by the R. Then it will be called as methyl. Then it is called as methyl. All of you have understood? Fine. Now, I have the methane. Okay. So from that, if I remove 2 hydrogen, then there can be other element CH2R, right? Then we can have other element. What do you mean by R? R is nothing but Raghavendra sir. Okay, R is nothing but any other element other than the hydrogen. Any other element other than the hydrogen. That's where we have the another category where methane can be converted into another category, derivative. Now this can be represented as CH2. This can be represented as CH2. Now this is called as methylene. This is called as methylene. So try to differentiate between methane and methylene. So methane, 4 hydrogen attached to the carbon. Carbon is satisfied because all these 4 bonds has been formed. Now it can be converted into methylene by removing the 2 hydrogen with other element. Now also carbon is satisfied because 4 bonds are there. But only thing here is it is having only 2 hydrogen attached to them. Then it is called as methylene carbon. Now here on the other side, if I remove 1 hydrogen from the methane, then I am going to get the methyl group. Even methyl group is satisfied. Carbon is satisfied because here also it is having 3 plus 1, 4 bonds. So therefore, what I mean to tell here is methyl or methylene both are derived from the methane. Both are derived from the methane. All of you have understood? Any doubts? Now, when I am representing the methane, observe it carefully. It's actually 3D structure. Whatever I have written, it looks like it is a planar structure. It's not a planar structure, it is actually a 3D structure. But how to represent on the board a 3D structure of methane? Right? How to represent it on the board? So therefore we can assume, we have assumed some of the symbolic representations. See, for example, when I am writing 2 hydrogen like this with one particular bond dash, then these 2 hydrogen, they are present in the same plane. They are present on the board. Okay? Now another carbon, observe it carefully. Another carbon, means another hydrogen, I will show like this. That means line is becoming thick as it is going away from the carbon. Line is becoming thick when it is becoming near to the hydrogen. That means this hydrogen is facing towards the observer. This hydrogen is actually facing towards the observer. Okay? Now another hydrogen. Okay? So that's where we have the another hydrogen. So in this case, hydrogen is going away from the observer. That means it is behind the plane. It will be behind the plane. Because that broadness of those line is becoming less. So that means that hydrogen is behind the board. Try to understand. this broad thick line where broadness is becoming larger towards the hydrogen. That means this hydrogen is facing towards me. That's what we are going to represent. And this hydrogen, where this dotted line, these lines, that the length is getting decreased towards the hydrogen. That means it is going away. That is, that hydrogen is behind the boat. That's what we have to assume. This is how in organic chemistry a 3D structure will be represented. Because carbon is a tetravalent, so it can make 4 linkages. All the 4 linkages will not be in the same plane. Some of them will be behind the board, some of them will be towards the observer, and some of them will be on the plane. So therefore, this is how we are going to represent. All of you have understood? Any doubts? Any other doubts, Sidhya? So that's what, when I am talking about methane, it can be converted into methylene or it can be converted into methyl, depending on how many hydrogen has been replaced. Okay? All of you have understood? Now, when I am talking about the molecules, where it is applicable, sir, that's fine. Why are you eating our head? What methyl, methylene, so many times you are telling? That is because when you are writing the molecules like hydrocarbons, for example, if I write ethane, okay, so this is the proper structure of ethane. Do you agree? No, this is wrong. This is not the proper structure of ethane. Why? Because carbon is having only 3 bonds. That's why it is not a proper structure of ethane. This is wrong. Okay? Many students in urgency, they will do like this and they are going to lose the marks. So ethane means where 2 carbons will be present, linked to each other by a single bond. 2 carbons are linked to each other by a single bond. Okay? That is one thing. But carbon will be satisfied, but only 1 bonds are there. That means each carbon can make the 3 bonds with 3 hydrogen. Each carbon can make 3 bonds with the 3 hydrogen. That's where I have the ethane. Okay? So if you observe it carefully, this is one methyl group, this is another methyl group. Right? So this is one methyl group and this is another methyl group. That's where we have the 2 methyl group attached to each other to form the ethane. Okay? All of you have understood? Fine. Now if you go back to chemical bonding, that's why I told. Those are some of the topics which will be very, very important. So in case of chemical bonding, all of you have studied about hybridization, right? So therefore, in case of the ethane, since it is an alkane, anyway, you are going to study about these molecules in your hydrocarbon topic also. Okay, I will give a brief introduction. Alkanes, where each carbon they are sp3 hybridized carbon. Each carbon they are sp3 hybridized carbon. Okay, how to find out the hybridization of a carbon? Just calculate the number of bonds and just find out any lone pair of electron if it is left over. If you include those things, hybridization is done. Say for example, if I consider this carbon, total how many bonds are there? 4 bonds are there. And nothing is left out with lone pair of electron. That means 4 bonds. So therefore I should have the 4 hybridized orbitals. So 1 belongs to S and 3 belongs to P. So total 4 hybridized orbitals. So therefore it is sp3 hybridized carbon, sp3 hybridized carbon. All of you have understood? Right? So methyl attached to each other to form the ethane, which is an example for alkane, where carbon will be having sp3 hybridization. Any doubts? Any doubts? Okay. Now, next I will write. Now we have discussed about ethane. Next I will write it as CH3, CH2, CH3. So this one I will call it as N-propane. This one I will call it as N-propane. Another example for alkane. Like ethane, we have the N-propane. What is the hybridization of carbon in N-propane? Anyone? What are the hybridizations of carbon in N-propane? All of them, they are having sp3 hybridized carbon. All of them, they are having sp3 hybridized carbon. So that's where we have got the N-propane. Yes, Ashish, you are right. Okay, they are having sp3 hybridized carbon. Stephen, what is that 3? I think you wanted to talk about sp3, right? So they are having sp3 hybridized carbon. Now if you observe it carefully, what is this? What is that center carbon? Can be called as? Center carbon can be called as? Which form of methane? Center carbon. I will block other two carbon. Just mention which form of methane it is. Anyone? Which form of methane? If I block CH3, only center carbon if I take, which form of methane it is? Anyone? All of you getting my point? So I will remove this CH3, then this CH3. Only that one. Which carbon it is called as? In case of the ethane, methyl group attached with methyl group. But in case of N-propane, yes, all of you right. It is methylene. Very good. It is methylene. That's what we can observe there. It is nothing but methylene carbon. That means methyl carbon and methylene carbon, right? And methyl carbon and methyl carbon. Now if you observe it carefully, for ethane I have not written it as N-ethane. That is because ethane will be present as a 2 carbon molecule and always it will be non-cyclic. There is no question of cyclic. For cyclic structure to form, minimum 3 carbon should be there. Okay? Therefore, to form a cyclic structure, there should be presence of minimum 3 carbon. But in case of the ethane, we have only 2 carbon. So there is no question of cycloethane. Cycloethane does not exist in the nature. It is impossible. So therefore, when I am writing ethane, I will write it only as ethane, no N-ethane. It will be wrong. But when I am talking about propane, if I am writing the linear structure, I will write it as N-propane. That is because we have another propane where 3 carbons, they are forming the cyclic structure. 3 carbons, they are forming the cyclic structure. All carbon will be like methylene carbon. All carbon will be like methylene carbon. So therefore, this is called as cyclopropane. Now I will call this one as a cyclopropane. All of you have understood? So that's where we have the ethane and propane. Now whatever I have written on the right side, it is cyclopropane. Okay? So why cyclopropane? Because there is no methyl group. Listen to me carefully. In cyclopropane, there is no methyl group. but in N-propane we have the 2-methyl group. Okay? So whenever methyl groups are present, it talks about the terminals. Free end. There is a terminal, free end. Whenever there is absence of methyl group, that means there is no terminal end. That means it should be a cyclic structure. Try to understand all these things. So therefore we have the N-propane and cyclopropane. Fine? All of you have understood? Any doubts? Any doubts related to this? ಏನು ಸರ್, ಬೆಳಗ್ಗೆ ಬಂದು ಮಳೆ ಹೊಡಿತೀರಾ, ಡೌಟ್ಸು ಕೇಳ್ತಾ ಇರ್ತೀರಾ, ಓಕೆನಾ? ಐ ವಾಸ್ ಜಸ್ಟ್ ಕಿಡಿಂಗ್, ಬಟ್ ಪ್ಲೀಸ್ ಟ್ರೈ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಲ್ ದೀಸ್ ಥಿಂಗ್ಸ್. Any doubt, no need to hesitate, you can raise the questions, you can type the message. Okay, that's why we have the N-propane. Okay, so I will write another molecule which I had written earlier also. CH2, CH3. So which is this molecule? Yes, Ashish and Rohan. Yes. So which is this molecule? This is nothing but N-butane. This is nothing but N-butane. So why I am writing N? N talks about linearity. There is a terminal. That's what N-butane talks about. Because we have cyclobutane also. Just before we have discussed, even we have the cyclobutane. CH2, 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 CH2. So this is cyclobutane. So other than the ethane, all the other molecules we can represent it as N or cyclo. I did not hybridization properly understood. Okay. Oh, okay. But it was done in chemical bonding, right? Anyway, don't worry. So what I mean to tell you is it's very easy to find out the hybridization. For example, if I take methane, hydrogen, 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 hydrogen. Now according to hybridization theory, a chemical bond will be formed only between the hybridized orbitals. A non-hybridized orbitals cannot make the chemical bond. So in that way, this carbon in methane, it is having the 4 bondings. That means there should be presence of 4 hybridized orbitals. Okay? So which are those 4 hybridized orbitals? S1 and P3. 3 plus 1 is 4. So therefore it is sp3 hybridized carbon in methane. Okay? But when it comes to double bond and triple bond, it will be a different scenario. Anyway, which we are going to discuss in the next class. Don't worry. So I will discuss briefly in the tomorrow's class. But any doubts here other than the hybridization? With respect to methane, why it is sp3? All of you have understood? Because it is having 4 chemical bonds, 4 covalent bonds. That's why it is called as sp3 hybridized carbon. Where S1 we will not write because it is understood. Therefore, we will omit the 1. We will simply write it as sp3. It's understood that there is a 1. Okay? So all of you have understood? So try to practice at your home. Okay? And tomorrow once again we will continue. Okay? Fine. So what we have discussed today? So today we have discussed about organic chemistry. What do you mean by organic chemistry? Then we have discussed about organic compound. What do you mean by organic compounds and all? Then we have discussed about classification of organic compound, where when it comes to the classification, we have the cyclic and non-cyclic. Non-cyclic can also be called as aliphatic organic compound or non-cyclic organic compound. Okay? Now when it comes to the cyclic, we have homocyclic and heterocyclic. and each of them further classified as aromatic and non-aromatic. Fine. But when it comes to homocyclic aromatic compound, once again it can be classified into two. One as benzenoid and another one as non-benzenoid. Okay, then we have discussed about what do you mean by methyl carbon and what do you mean by methylene carbon. Then we have discussed about ethane, propane and butane. And what do you mean by that N-propane? N-butane talks about. Okay. So anyway, tomorrow we will continue. Thank you. Thank you. Take care. Bye.